All right, hi everybody, welcome back. Subtopic number 5 on hearing and noise, the final one. So hearing loss and noise control. This is where we start talking about the safety aspects of loud sounds and exposure to sound, to loud noises. And then what do we do about it? How do we engineer around these safety risks? Okay. All right, so first of all, I've mentioned in several of these lectures here, we're all slowly losing our hearing. So basically, just like with vision, we age, our cornea becomes less transparent, the lens becomes less transparent, the lens becomes less flexible, the muscles weaken. As we age, our sensory systems break down, and our auditory system does as well. So the conductive tissues in the ear, all of those complexities that transform, the oscillating pressure into neural impulses eventually break down with years and time. Now, there's actually not a direct linkage between age and hearing loss. However, there is a direct linkage between age and hearing things. So the longer we live, the more we hear things. That's really what it is. It's just noise exposure over time. It's just when we age, we have had more time for which our ears to be exposed to sound, right? As I mentioned several times, we especially lose the higher frequency end of the spectrum. So I think I said something like above 10,000 hertz might be lost for people that aren't suffering from that extreme of hearing loss. So this kind of shows, 8,000 hertz is heard at about 50% of, I don't know, whatever, but considerably less than when we were younger and didn't have hearing problems as much. Actually, and I mentioned this already, I think too, it's really interesting to map out the highest frequency that people can hear by age, because it actually follows this pattern fairly consistently. Okay, so yes, the younger we are, the higher frequency we can hear. This reminds me of another thing. So there are apps and like little tricks that can be added to phones where hypersonic, like really high frequency sounds are used to signal, and only young people can hear them. So it's like a legitimate way to have like stealth conversations in class or something. So all right, anyway. Good news is, just like with vision, we have the ability to correct for when our senses aren't as good as others. So hearing aids, these are going to be familiar with everybody. What you might not know, though, unless this is something that either some of you wear or loved ones, this is not just a microphone that amplifies everything around you. Hearing aids are specialized and they're very expensive because of what they do to only amplify certain parts of the audible spectrum. So every individual person with hearing loss has a unique loss. Basically, the way that their hearing tends to fade with time is unique to the person. So there is a physician who you would work with to determine exactly which frequencies am I having problems hearing, and those would be amplified while everything else kind of stays at a normal level. And that's good, because you don't want, just because I can't hear the grandchildren hissing at me, yelling at me excitedly, doesn't mean I should turn up the entire volume of the whole movie, right? So we only pump up that one end. Okay, I've used the term sound and noise fairly interchangeably throughout these subtopic lectures, but they are considered to be different things. So sound is the general quality of the energy. Noise is a type of sound that is annoying, that we don't like, that is undesirable. Okay, so noise either makes things harder to distinguish what we're trying to hear from a background, it masks things, and noise is also generally what we talk about as like, this is what you have to worry about in an environment where there are loud sound levels that you need to be able to manage. Noise is like meaningless loudness, right? It tends to have high entropy, meaning it's chaotic, the sound. But it really, what's noise versus what's just information carrying sound really depends on your perspective and your context. So, this is beautiful sound for these guys, but it's noise for, I don't know, noise for these folks, I suppose, or that poor guy. It doesn't have to be a loud, like damaging sound. It can be annoying. A mosquito in a quiet room, for example, not going to cause you hearing damage, but it is unwanted sound, right? All right, there you go. And some of the noise is damaging. So like a table saw, this is where we start talking about, okay, that's an unpleasant sound, but is it unpleasant and also at a dangerous level of, sound pressure level? Most jobs involve some kind of noise in the environment, and this is something to keep in mind. We're not just talking about industrial settings where everybody is wearing, hearing, protection. There are a lot of everyday jobs, including kindergarten teacher, that might be facing a consistent and significantly high levels of noise. All right. So problems with noise, they can mask important signals. I didn't hear that phone call coming in because of all the unnecessary sound around me. I did mention this in one of the earlier subtopics, this concept of a temporary threshold shift. And what that is I can best describe it as that when you leave a concert with all of your friends and you've just been listening to really loud sounds and screaming all night, or maybe a football game, Aggie football game, that's going to be a loud place. And as you leave, there's a couple of hours where everybody in the car is kind of yelling at each other, and you don't realize, the volume around you has dropped to a normal level, but inside your head, you're yelling, hey, can you hear me? And they're right next to you. So if this is, familiar to you at all, this is experiencing what we call the temporary threshold shift. This is something that lasts a few hours generally, recovers with time, but it can be pretty extreme, right? So we can have 60 decibels of temporary threshold shift after 100 minutes at a rock concert level. So that's a pretty substantial shift where things are perceived as that much less, that much lower in sound pressure level than they truly are. Now, the bad news is you can also have permanent versions of this, and that would be obviously with some severe, damage to the tissue, to the receptors. And this is, ultimately the bad stuff we're trying to avoid. And so OSHA, the work police, they give us the rules, and they say your workplace, in order to be, up to the standards of the Occupational Safety and Health Administration of the United States, needs to meet these specifications. Otherwise, you need to change things about your public workplace. OSHA.gov, you can check it out there. You've heard me mention them a few times. This is probably the most, the biggest overlap with, what is OSHA and this class has to do with hearing protection. Okay, so here's the table. Now, this is published by OSHA. I don't know how long it's been since it's been updated. It's been pretty consistent. But the key here is to assume an 8-hour work shift. And if people are working in an environment that is 90 decibels of A, they can have exactly 8 hours a day that's permissible of being exposed to that before OSHA steps in and says it's too loud. 8.1 hours at that, too much, we have to change something. Or if it's 8.0 hours of anything higher than 90 decibels of A, then then they really start to cramp down. Okay, so you'll note though, we've gotten if we can't go above 90 in 8 hours, why do we have all these other things? Because typically you're not like having a noise source blasting in your face continuously for 8 hours. You are maybe going and operating the table saw for 20 minutes at a time. And the table saw is maybe 110 decibels of A, okay? It's gonna be pretty loud. Those machines are likely louder than these in a lot of cases, industrial machines. So, all right, well, if I'm on an 8-hour shift, but I only spend 20 minutes on this table saw, what this is telling me is, okay, well, I'm under 20 minutes, I'm under the allowable allotment of 110 decibels of A. But what does that mean if after I turn off the table saw, the background environment is still at 100 decibels or still at 95? So what we end up having to do is combine the noise dosage from multiple different sources over the course of a day to come up with one mathematical number that is, this is how much noise you have experienced today. Okay, so the noise dosage, this is what it is. So we're going to use this table, and we're going to basically use exactly the values here and this equation. Okay, so the dose we're receiving, and if the dose is 1.0 or greater, OSHA says you got to fix it. Okay, so the actual amount of time I'm experiencing a decibel level of noise versus, or divided by the allowable time, the exposure limit according to OSHA. So if I'm doing this handheld saw right here with this guy, or this hand saw, it's not a handheld saw, just you're doing a lathe or whatever this machine is. Say I take my sound meter up to it, it's 95 decibels of A. So I know if I get 8 hours of this on, I'm over the limit. But I want to know, well, what's my noise dosage from specifically this machine if I'm only at it for, you know, a few minutes at a time, or 10% of my shift, I should say that this is on. All right, so 95 decibels of A and 10% of 8 hours, that's all I need to know, because I will go to 95 decibels of A here. I get 4.0 hours, that's all you get. And if I compare 10% of 8 hours, that's the actual amount of time I'm exposed to it, divided by my limit, I get 0.2. So that is the dosage. 0.2 is the noise dosage for just that machine. Now I have to consider all the other noise sources if I want to get really serious about this, okay? And I add them. I would add them to 0.2. So if this same guy goes over, you know, and spends 50% of the day at a different machine with a different noise dose, you know, with a different produced sound level, you would add the dosage from that machine on as well. Now, the audible spectrum is interesting because we actually have physiological bodily responses to sounds that we can't necessarily hear. So sounds that are actually outside of our audible spectrum, we can still have bodily reactions to, because they're still oscillating pressure waves, right? So just because our ears don't have, you know, neural hair receptors that correspond with that specific frequency doesn't mean we're not affected by it, right? So infrasonic, below the audible spectrum, a lot of earthquakes, extreme weather, there's you know, a reason why some animals get all nervous and jumpy when extreme weather is coming. And a lot of it has to do with they're probably hearing these subsonic, these infrasonic frequencies as they pop, you know, the low frequency oscillations travel further. And so, you know, things like giant storms are more likely to create these large pressure differentials, earthquakes, right? Right. Yeah, this is interesting. So I've read, heard, seen a few things that, you know, involving like ghost adventures and stuff, and haunted houses, and how does this happen? And one of the, you know, and this isn't obviously always the case because ghosts are real, but one of the ways that people have, you know, labeled places as feeling haunted, feel like people walk in, they're like, it feels creepy in here. Why? And in some cases, they'll find, oh, well, there's actually a really low frequency sound source somewhere in this vicinity, like a really old circulating fan, for example. And if it has a frequency that is below 20 hertz, but is powerful enough, you know, to affect people, what happens is you get like oscillations of the fluid in the eye that are responding to the pressure. You get, you know, the fluid of the body and the chest cavity is affected by these oscillating pressure waves. So these all kind of contribute to this psychological response of dread. I also like to point out that tigers, if you measure the growl of a tiger, parts of it are right at about 20 hertz. It's a very low frequency sound, but some of a tiger's growl is subsonic. It's below infrasonic. And so I also like to say, well, that's the sort of like creepy aspect, the extra terror that's carried, you know, with a tiger growl. So I like tiger growls in particular for really messing with emotions. And we have exposure limits, time limits for these as well, okay? So just because we can't hear them doesn't mean we can bask in that pressure wave all we want, right? So 20 hertz all the way down to 1 hertz, we have these ranges as well as far as what we can experience. Ultrasonic as well, okay? So it's higher than I can hear. Things like really high speed tools, dentistry is a great example of this, may have these frequencies being emitted, and this guy's ear is right next to it. So if he's doing this all day, that's something to consider, right? In terms of the hearing exposure, in that context. So 110 decibels a day is the 8-hour limit for ultrasonic. You'll note there we're allowed to go a lot higher for these higher frequency sounds. And again, I'll point out that that really high frequency sound is more knocked down by distance than the low frequency sounds. Impulse noise is basically gunshot sorts of noise. So it's something that has a very large pressure change in a very short amount of time. And so you can imagine like huge amount of pressure really yanking at your at your tympanic membrane, at your eardrum there. And this can rupture that membrane like so. So this would be an example of an impulse injury, impulse noise injury. It can heal, it can be fixed and all that. But this sort of situation, that might be the kind of thing where something really loud happens and you feel, like the ear might bleed, for example, if it gets a really violent sort of exposure to pressures. But you'll also probably have at least a temporary significant reduction in your hearing. So yes, so anything that's like incendiary, explosive charges, firearms, any sort of construction equipment that's designed to exert force, right? All of these things are, have a risk for impulse noise. All right. So OSHA. So we know how to calculate our dosage, and that's literally like the equation that OSHA police might use to determine if there needs to be changes, in your facility. Excuse me. But there's actually 2 thresholds here. So 90 is the one where, okay, now you got to make changes. Now it's going to cost you, boss, because you have to buy hearing protection for everybody or whatever. But at 85, there's also sort of a soft threshold there, a soft requirement where, all right, at that point, you got to give people hearing protection. You got to give them at least ear plugs that can go in the ear. You got to give instructions on how to put them on, and you have to test your workers regularly, to determine if anybody is having, like an accelerated loss. So that's a requirement. It's a soft, you don't have to change very much, but at 85 decibels, that's where you got to start taking action. And at 90, now you got to move that machine. You got to get a different machine, or you got to do more drastic things to protect your workers. These 5 categories are what are suggested kind of roughly to be considered if your workplace is pushing or at the 90 decibels. First one, we can mask the noise. We already know how masking can occur in unwanted conditions, like when 2 people are talking with similar voices and one overlaps the other. Now, this doesn't make the sound level go down, but it does mask annoying or things you don't want to hear. So white noise, for example, is used a lot of times when there's almost continuous sort of unwanted noise, like you're in a big city, for example, and so the white noise helps block out the external city life noise, right? Doesn't make it quieter, but it helps mask it so there isn't any like attention grabbing sorts of sharp sounds. Noise canceling technologies, some of you may have these, have this in your current, in your current set of earbuds, headphones, whatever. But there's essentially an algorithm where if you can sample a fairly consistent noise in the background, airplanes are a great example of this. The background noise in an airplane is a fairly consistent signal. And if you've got a microphone in these devices that can sample that signal and could reproduce the opposite waveform of that signal. So again, remember, this is just pressure waves going higher pressure, lower pressure, higher pressure, lower pressure. If I negate that and I superimpose low pressure in a high pressure moment, and look and high, if I basically give the inverse signal here, those waves can essentially neutralize and become the absence of any pressure wave. So this is how noise cancellation works. It's also important to know this won't work for sharp, non-continuous sounds, because again, you need that microphone to pick up on the background sound to be able to produce the inverted version of that sound, right? And so that takes some time. And if there's a sound right now, the technology won't have time to catch up with it. All right, so masking is one option. Option two could be that you plan ahead, and what that means is assume that the noise is going to be loud at times, and what can we do, to make it less of an exposure risk for our workers. So you can redesign procedures, you can relocate things, right? Choose different equipment that doesn't make as much noise. Remember in the very first lecture, was it the very first or the second one, where we talk about sound power and how you can actually have a device, or like an appliance, for example. There was a washing machine example where you sample all of the sonic energy coming out of it, and the sound power is something that is like a characteristic of that product. So you can buy a quieter device. Yes, it might be more expensive, but that's a consideration. Yes, most inexpensively, let's take the loud things like, for example, the air handling units, and let's put them in places where people are not. So you'll notice, in Texas, most major, public buildings have their air conditioning and that whole unit on the roof, or in a place that humans are not walking in and around, because it's loud. It would be disruptive to most campus activities if they were, right next to a lecture hall, for example. Also remember, distance is the great, quieter. And so empty field conditions, we are attenuating 6 decibels for every doubling of distance. And similarly, 8 decibels that's how much is attenuated if we have sound absorbent material. So if we're trying to absorb more of the sound, more of it is absorbed when we half the distance, so you're attenuating that much. Okay, good. Option 3, realize that sound is gonna be there, and see what you can do with existing equipment, with existing arrangements, to make it less damaging. A lot of machinery can be modified in terms of how fast they operate. Higher frequency sounds are more irritating, they're not necessarily more damaging, but they might be less pleasant. So you can change the operating speeds of machines. Interesting also is that you can get resonance. So if multiple machines are running at about the same speed in one space, they all kind of have a synchronized wave pattern. This can amplify and ultimately make that noise louder and louder if they resonate. So what you can do is change the speeds on some of the machines so that they don't have a resonance that disrupts that resonating pattern that would be getting louder and louder, more and more dangerous. Air turbulence and velocity, minimizing moving air. Moving air is the great, that's the wild card with any sort of noise control, because sound is moving air, right? So wind, for example, there's a reason why wind goes by and we can hear it, because it's a pressure change. So that's going to add to, what's going on in your noise spectrum as well. Number 4, we modify the sound wave that we have. So remember, we talked about how lower frequency sounds tend to travel further. And so you can't do as much with those, right? So, but if you fully enclose it, that helps. Otherwise, anything that's a higher frequency sound, you can knock down quite a bit, with barriers. So this drum set, for example, this would be very reverberant in that space. But the higher frequency cymbals and things, you can really knock down that reverberation, with a drum shield like this. But yeah, also, like I said, if I have this trunk closed, I'm still going to hear the bass on the outside. And you hear a lot more of it if there's room for the air to escape. If it's a completely closed system, it's much less of a impact. But if you had a little, like if you shut this trunk and you had a hole drilled, just a 1/4 inch bit hole drilled through it, it would be way louder than if that hole was not there. So interesting, interesting sort of thing with low frequency containment. Yep, the light and porous materials will absorb sound, blocking high frequency with barriers like with the sound, with the cymbals and the drum shield there. High frequency more annoying than low frequency sound, and it's more easy to attenuate high frequency sound. All right, last one. So all those other things fail or aren't available, or even if they are, one of the easiest steps to take is to buy personal protection and to enforce it in your working group. So now there's several different versions here. You can get these full ear muffs. These work the best. They're going to be the most protective of your hearing, but they're also the most awkward. These, in-ear plugs, and I've got, several of them next to my drum set over there for when I'm playing drums. Those are great, but people got to wear them, right? And so these don't work quite as well as those. But yes, this is always the problem, is getting operators to wear them. All right, so in the end, you probably ought to have some hearing protection for your workers if you're anywhere near these OSHA limits. It's probably not the only thing that you can do, or should do, to keep it a healthy work environment, however. Okay, folks, that is it for topic 7, hearing and noise. Hope you liked it. Tune in next time for topic 8, supporting cognitive functions. All right, enjoy the week.